Hi, so today we're going to talk about inductive reasoning and conjecture. So, first of all, inductive reasoning is just reasoning based on patterns. So, if you notice a pattern of numbers or a pattern of any sort, it's called inductive reasoning. So, I have patterns on the butterfly. A conjecture is just a fancy word for saying it's the conclusion that you reach using inductive reasoning. So you're going to have some problems today where you have to figure out the next term. So like this one, 38 to 31. What is happening? How do I get from 38 to 31? Well, I would subtract 7. How do I get from 31 to 24? I would subtract 7. How would I get from 24 to 17? I would subtract 7. So my next term would be 10 because 17 minus 7 is 10. And my conclusion is subtract 7. So that's how I got that. So you're going to go through and you're going to try to find the next terms. I know it says the next 5 terms. Let's see. Did I put all the next 5? I sure enough did. So on your notes page, I don't know if you need to pause the screen. Can you see it? If you need to pause to get these. So like on the next one, you would just double the previous number. So 2 times 2 is 4, and then add 1 to that. So 2 times 2 is 4, plus 1 would be 5. 5 times 2 is 10. Plus 1 would be 11. 11 times 2 is 22, plus 1 would be 23. 23 times 2 is 46, plus 1 would be 47, and so on. So I just wrote double the previous number, then add 1. The next one is the perfect squares. 1 squared is 1, 2 squared is 4, because 2 times 2 is 4. 3 squared is 9, because 3 times 3 is 9. 4 squared is 16. So then 5 squared would be 25, 6 squared would be 36, and so on. So I just wrote 1 squared, 2 squared, 3 squared, 4 squared, and so on. The next one just skips 2 letters in the alphabet. So we start with A, then we skip B, C, and then we have D, and then we skip E, F, and then we have G, and so on. So it skips 2 letters in the alphabet. Now, really important sequence of numbers, really important sequence of numbers is this one right here. It is called the Fibonacci sequence, so it will be on your test. It's really important. So this pattern is you add the 2 previous numbers. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. So just do 13 plus 21 to get the next number. Okay, so this is something else for your notes. A counterexample is an example that shows a conjecture is false. So what you have to do on problems like this is you really have to kind of think. So like number 1 says, the sum of any 2 consecutive integers. That means numbers right next to each other, like 1 plus 2 or 2 plus 3. So it says the sum of any 2 consecutive integers is always odd. So let's think about it. 1 plus 2 is 3. That's odd. 2 plus 3 is 5. That's odd. Let's try 5 plus 6. 5 plus 6 is 11. That's odd. So that would be a true statement. So we don't have to find a counterexample. The next one says the product of 2 numbers is always larger than either number. So like if I multiply 2 times 3, I get 6. 6 is bigger than 2 or 3. But what if I multiply 2 times 1/2? Then I'm going to get 1, which is smaller. That would be a counterexample. So you would say false, and then give me your example. The product of 2 perfect squares is always a perfect square. So let's think about that. 2 squared is 4. 3 squared. So 2 squared is 4. 3 squared is 9. If I multiply 4 times 9, I get 36. which is a perfect square because 6 times 6 is 36. So that one is true. If the area of a rectangle is 6, then the sides must be 2 and 3 because 2 times 3 is 6. But what about, that's going to be false because what about 6 times 1? 6 times 1 is also 6, so that would be my counterexample. So you just show an example proving it false. So dividing by 2 always produces a number less than the original number. So like if I do 8 divided by 2, I get 4, and that would be less. But what if I do negative 8 divided by 2? Then I get negative 4, and negative 4 is actually greater than negative 8, so that would be false. And then the last one says vertical angles are never complementary. Well, complementary angles just add to 90. So what if your vertical angles happen to be 45? 45 plus 45 is 90, so then that would be false. So those you kind of really have to think about. Let's see. Oh, here's my joke for the day. Are monsters good at math? Not unless you count Dracula. Anyway, so on your assignment, the first ones you have to try to figure out the next number in the pattern. So let's see. Number 2 is pretty hard. Number 2 is pretty hard. Let's think about it. So to get from 1 to 2, what would I have to do? Well, I could add 1. I could multiply by 2. Let's see what happens from 2 to 6. What would I have to do to get from 2 to 6? Or 6 to 24. When the numbers start going up really fast, really big like that, think multiplication. So 1 times 2 is 2. 2 times 3 is 6. 6 times 4 is 24. 24 times 5 is 120. So just do 120 times 6 to get the next number, and then you'll do the next number times 7 to get that. So the conjecture is multiply by next number. Multiply by the, here let's say the next consecutive number. So that one was kind of hard, I think. Let's do another one that might be hard. Maybe number 5. Maybe number 5. Notice the numbers are getting much smaller really quick. So if they're getting smaller really quick, think division. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 2 is 1.5. 1.5 divided by 2 is 0.75, and so on. So this would be dividing by 2, and you'll have to do 0.75 divided by 2, and then that number divided by 2. Now this one is the Fibonacci sequence. Very important. Fib sequence. Add to previous numbers. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. And 8 plus 13 would be 21. So that's how you do that one. That one's really important. You will have that on the test. 9 and 10 are kind of different. They're just kind of fun, I think. So number 9, think about the months. January, February, March, April, May. So then it would go June, July. 7 months. Oh, I put months. Months. And then the next one, think about counting. 1 starts with O. 2, 3, 4, 5, 6, 7, 8, 9, 10. Counting numbers. Okay. Then you've got some more patterns that you have to do. These are the ones where you have to come up with a counterexample if it's false. So like number 13 says the difference between two negative numbers is always negative. Well, let's think about that. So difference is subtracting. So if I do like -4 minus a -8, remember what happens when you minus a negative? It makes plus, which would be +4. So that would be false. So you're going to have to try to come up with a counterexample. Like, look at 15. All birds can fly. Is that true? That is false. What about an ostrich? I don't think ostriches can fly. So you're going to go through these and you're going to try to find a counterexample. If you need help with any of that, just let me know. Thank you.